Welcome to the second module of Biosafety Training at UW-Milwaukee. Module 2, Risk Assessment and Biocontainment, will discuss risk assessment in regards to work with infectious agents and biosafety levels of containment. Let's discuss biosafety levels of containment. Biosafety levels define the type of containment, equipment, personal protective equipment, and laboratory practices implemented in the laboratory to work with a biological agent. They are classified from BSL-1 to BSL-4, with BSL-1 being for the lowest risk agents and BSL-4 being for the highest risk agents. They are not tied directly to the risk group of an agent, because even though an agent may be of low risk to humans, it may be of high consequence to the environment, and we have to take that into consideration when we are looking at containment requirements for working with specific agents. Ultimately, determining the biosafety level necessary for the work that you're planning to do is done through an accurate risk assessment. You don't look at what a company says in a paper that they send when they send you a sample of the agent. You don't look at the risk group alone. It really looks at all of the different procedures and agents that you plan on working with, and then looking at the lab facility and the type of containment you're going to need to make sure that people and the environment are safe. Remember, the biosafety level is a containment level, and it integrates lab design, practices, procedures, and equipment. There are many guidelines regarding biosafety levels of containment, but the general features for each level of containment are standard. If you're not already a principal investigator, then the containment level for your lab has already been designated. Let's explore a little bit more about BSL-1 and BSL-2 containment. When is BSL-1 containment appropriate? BSL-1 containment is suitable for work involving well-characterized agents not known to consistently cause disease in immunocompetent adult humans and present minimal potential hazard to laboratory personnel and the environment. Examples of biological agents that could be safely potentially handled in biosafety level 1 containment include E. coli K12 and its derivatives and Saccharomyces cerevisiae. When is BSL-2 appropriate? BSL-2 is suitable for work involving agents that pose moderate hazards to personnel and/or the environment. The primary differences from BSL-1 include the training requirements, laboratory access, the engineering controls present, and the PPE requirements. Some examples of biological agents that may be handled in a BSL-2 laboratory include Staphylococcus aureus and Pseudomonas aeruginosa. There is also a BSL-2 plus laboratory grouping that is not an official containment designation. However, it is where people work in a BSL-2 laboratory, but they use BSL-3 practices, such as working exclusively in their biosafety cabinet, wearing respirators, or additional enhanced PPE. If you plan on working with the following agents, you will be required at a minimum to work in BSL-2 plus or higher, depending on what the Institutional Biosafety Committee decides upon protocol review. E. coli, Shiga toxin producing strains, hepatitis B virus, hepatitis C virus, human immunodeficiency virus, simian immunodeficiency virus, Zika virus, vaccinia virus or vector, rabies virus, influenza virus, except for the pandemic strains, which must be handled in at least BSL-3, infectious prions, Listeria monocytogenes, lymphocytic choriomeningitis virus, or LCMV, macaque tissues, oncogenes used in viral vectors, Salmonella typhi, Shigella dysenteriae, or Toxoplasma gondii. Additionally, work with any of the above materials will require an occupational health screening and routine medical surveillance at the expense of the laboratory principal investigator. These will outline the minimum criteria required for Biosafety Level 1, Biosafety Level 2, and Biosafety Level 2 Plus containment at UWM. In BSL-1, no special primary containment is required. In BSL-2, a currently certified biosafety cabinet must be used for procedures that generate aerosols. In BSL-2 Plus, personnel must use the biosafety cabinet for all procedures involving the work with the infectious agent. Secondary containment in BSL-1 includes a sink for hand washing, locking doors, surfaces that are non-porous and able to be disinfected, and windows that have screens and locks. In BSL-2, in addition to the requirements of BSL-1, the sink is preferably hands-free, the doors are self-closing, and the windows should be sealed so they cannot open. Training requirements are universal for BSL-1 and BSL-2 personnel. You must have completed biosafety training, which includes the principal investigator. Additionally, the PI is responsible for being appropriately educated or trained, or co-PI with someone who is trained to handle the infectious agents planned for their experiments. For personal protective equipment, all personnel are expected to wear the appropriate lab attire, meaning closed-toed shoes, no shorts or tank tops, and hair is always pulled back. In addition, all personnel in UWM labs should always be wearing a lab coat, safety glasses, and gloves. Splash goggles are required when there is a splash risk. In BSL-2 Plus, respiratory protection, shoe covers, bonnets, and disposable lab gowns may be required. All labs should be equipped with the appropriate glassware cleanup equipment, EPA-approved disinfectant, mechanical pipettes, and a biohazard spill kit. Regardless of containment, biohazardous waste must be decontaminated prior to disposal. For BSL-2 and 2 Plus labs, an autoclave must be on site, preferably near the laboratory. Personnel are required to post the appropriate door signage. Do not post agents on the BSL-2 or 2 Plus door signs if facing a public hallway. BSL-1 labs are not required to maintain a lab-specific biosafety manual, but should have standard operating procedures as needed and a SHARPS standard operating procedure when SHARPS are employed. BSL-2 and up requires a lab-specific biosafety manual containing standard operating procedures, protocols, and training logs. Biosafety inspections will be conducted biennially for BSL-1 labs and annually for BSL-2 and higher laboratories. It is also important to remember that no matter the biosafety level of containment, no plants or animals that are not part of the experiments are allowed. An integrated pest management plan must be in place, and you must have a well-maintained eye wash and chemical shower available. Let's investigate a BSL-1 laboratory. Laboratories should have doors for access control. The laboratories must have a sink for hand washing. The laboratory should be designed so that it can be easily cleaned. Carpets and rugs in laboratories are not appropriate. Laboratory furniture must be capable of supporting anticipated loads and uses. Spaces between benches, cabinets, and equipment should be accessible for cleaning. Bench tops must be impervious to water and resistant to heat, organic solvents, acids, alkalis, and other chemicals. Chairs used in laboratory work must be covered with a non-porous material that can be easily cleaned and decontaminated with appropriate disinfectant. Laboratory windows that open to the exterior should be fitted with screens and be able to be locked. In addition to anything just listed in BSL-1 laboratories, BSL-2 laboratories have additional considerations. An autoclave must be on site, preferably near the laboratory. An emergency shower and eye wash station have to be present. The door should be self-closing with a lock. Signage should be posted on the door. A biosafety cabinet is available for any aerosol generating procedures. The appropriate PPE is worn, including a lab coat, safety glasses, and gloves at all times. A sink for washing hands is available near the exit. There are non-porous work surfaces, and the windows are sealed. All of the criteria set for BSL-1 and BSL-2 are also applicable in BSL-3. Level 3 laboratories have additional design and engineering considerations. Personnel working in BSL 3 laboratories are required to have the appropriate education, training, and approvals to work in that laboratory. There are separate training requirements in addition to facility design, practices, and procedures. This is one example of a BSL-3 laboratory. Remember that each setup is different. There is a door sign with the biohazard symbol present, contact information, and entry-exit procedures. Do not post agent information on this door unless it is already located in a restricted space. Directional airflow indicators and security restricted access are required. This would include fingerprint scans, key cards, etc. The anteroom separates the lab from the outside space. In the staging area of the first entry would be a space to put on your PPE and prepare for entry. On the way out, ideally there is a one-way flow to account for decontamination of the personnel. Each biosafety level 3 lab may look a little bit different depending on the lab group's needs. All important communication should be posted on the entrance to the lab room space. This depicts an autoclave in the lab, which is fine, but ideally it is pass-through so that the decontaminated waste can be removed outside of containment. There should be a hands-free sink for proper hand washing near the exit. Additionally, double doors that are lock and are self-closing, cove molded floors that can hold a large spill, sealed windows, a lab-specific biosafety plan, and more are required. Remember, your lab may vary based on the work that you do. The criteria provided in this training is the minimum criteria necessary to work in your lab. Other requirements may also be determined by the Institutional Biosafety Committee. Plant biocontainment may require work in the segregated spaces of the greenhouse. Animal facilities work with the animal care program and have specific requirements in addition to the standard requirements for the respective biosafety levels. Teaching laboratories have unique considerations: personnel training, lab layout, the number of people working with agents at the same time, etc. This concludes Module 3, Biocontainment. Complete the short quiz to move on to Module 4.